The GSE93570 is a multi-omics data set composed of 3 types of data. You see samples of the RNA-seq, ChIP-Seq, and ATAC-seq. bigWig files, which are results of the first-tier analysis of FASTQ, are available as supplementary. Download the bigWig files of ATAC-seq and save them in a local folder. The file size varies from sample to sample. The largest one is about 700 megabytes, which is quite large. If you import the data as it is, a computer can easily overflow, so import only a specific region of the genome. Define a testing region, which should be about 10 to 20 million BP wide. Once you defined it in bed format with Excel, save it as a tab-delimited text file with the extension bed. Drag and drop the bed file to the Region Lists panel of Subio Platform. The test region is saved as a region list. Open the Genome view in Analysis browser and drag and drop the region list to visualize. Now, select one of the bigWig files and import it into Subio Platform as a sample. With generating a platform named Test1. In Import Option 2, filter measurements to import only those overlapping the test region. If you import the whole, you will generate 67 million measurements, but you keep it to about 500,000. Create a series and see what the data looks like in Genome view. The vertical axis of the graph is displayed from 0 to 200, with a scale line for every 50. Let's zoom in until we can see the shape of one peak. You see, this peak is composed of 1200 measurements. However, if you take out only the peaks, the number of measurements is reduced by half to about 600. If you import only the peak-related parts, you'll save a lot of memory. So, let's import the same sample, but only the part about the peak. In Import Option 1, import only those values that are greater than 20. As before, import measurements only in the test region. You see, the number of measurements is significantly reduced with the filtering. Create a series to take a closer look at it in Genome view. Adjust the scale of the graph as same as earlier. It looks like there are 5 peaks here. There are gaps between the smaller islands. Lumping these measurements which form peaks together would further reduce the memory consumption. Let's import the bigWig again to see how much memory you can save. The import option 1 and 2 filters should be the same settings as before. Import option 3 selects import intervals and puts together neighboring measurements. Adjust the intervals as setting two parameters, the maximum width of the gap and the minimum size. Thus, they were grouped into only a few hundred peak regions. Create a series and check it out in Genome View. You use the same scale as before and draw the graph. When we get to this number of measurements, we will be able to see the whole genome. Let's import the whole genomic regions of all samples with the filtering and intervals as you tested. Import all the bigWig files to Subio Platform with generating a platform named GSE93570ATAC-Seq. Import option 1 will apply more than 20 filters, import option 2 will not be used this time. Import option 3 creates and imports intervals with the same settings as before. In each sample, they are grouped into peaks of about 15,000 to 25,000 locations. Notice that the number of measurements is over 280,000, which is quite large comparing to the peaks per sample. Create a series and see why it happens. Extracts the parameters of each sample from the file name and divides them into separate columns. Modify the dataset and visualize it in Genome View. There was a group-specific protruding peak in ULFR 151 GFP. Let's zoom in. You see that the position of peaks in each sample is slightly different, even though it is in the same area. If you drag the peaks of the 4 repeated samples around, you can see that the measurements are different. For the subsequent analysis, the tools in Advanced Plugin and System Plugin will help you.